We're going to actually use this part of the calculator a bunch in the next set of units, so it's good for us to get comfortable with it. The probability distributions are here. They're in this distribution menu, which is you access by doing second and the vars key. Vars for variables, it's right next to clear. So second vars gets you your distribution menu. And these are all different probability types of distributions. Normal distributions, the inverse normal, a t-distribution, something that's called a chi-squared distribution, the f distribution, the binomial distribution, the Poisson distribution, the geometric distribution. They're all different types of probability calculations for different continuous and discrete variables. We are going to use, if I arrow all the way down to once I get to the letters, letter A, the binomial PDF. Now, the one past that is CDF, and you got to be careful. The CDF one, you can use it a little bit differently. My recommendation, we're going to stick with PDF for today, because anything, you can do everything with PDF. So we're going to choose that. And when we choose that, we're going to get a menu, or an entry screen. Get some things off of here. Okay. Let me write this down for a minute, what we just did. So let me move this. So how do we use our calculator? We're going to do second and the vars key. Whoosh, there we go. Second and the vars key, because that will get us to the distribution menu, which has all different kinds of probability distribution, basically different work that we can do for probabilities of different kinds of continuous variables. Okay. And we want to choose arrow, get all the way down to A. So we have the binomial PDF. Binomial probability distribution function. All right, so when you get to the screen, it tells you exactly what it needs to do your formula. It says, okay, tell me how many trials you're doing. We're doing 10 questions. What's the probability of success? On any one question, we have a 1 out of 4 chance of being right. What do we want to figure out the probability of? Well, we want the probability of getting 0 of them correct. When you enter on paste, what it's going to do is it's going to come back to this screen, and it has the binomial PDF operation there and the 3 numbers you need to use in the right order. Okay? Binomial PDF NPX. And if you press that, it does exactly what the formula does. You don't see it do it all, but it does it. It's built in to do the formula, and there's the 0.056. The nice thing about this, one of the things I love about this function is, let's say we wanted to do, like on the next problem, it says, what's the probability of getting exactly 6 in the same question? I don't have to start back at the beginning. If I do second and enter, it's going to reprint. It's going to say, okay, this is the last thing you did. You did this binomial PDF with 10 and a fourth and 0. And I can say, all right, well, I want to do the exact same thing with 10 and a fourth, but I just want that now to be 6. Boom. I don't have to start back at the beginning. I absolutely can. Okay. I can get to my distributions, get down to the binomial PDF. It's still 10 trials. It's still 1 out of 4. I want 6 correct, 6 successes. But once you kind of have that on your screen, you can reprint it on your screen and just change the values. As long as you're doing the same problem, the N and the P would be the same. The X would be the only part that would change. If you're switching to a different problem, you would have to change the N, the P, and the X. So what do we say? 0.016. 0.016. Okay. I could do it this way. If you're like, I don't like that, Mrs. Willenbrock, can I just not use the formula? Absolutely you can. There it is. 10C6. 1/4 to the 6th, 3/4 to the 4th. So, please find for me now, what's the probability in this scenario of getting at most 3 correct answers? So what's the probability that X equals 3 or 2 or 1 or 0? See if you can find that value for me. What's the chances of getting 3 or 2 or 1 or 0 correct? That's 4 calculations. Well, we already know the 0 one. That's 4 calculations, but the calculator can do those for me pretty quickly. So what's the chance of getting 3 correct, 2 correct, 1 correct, 0 correct? What's the chance of this or this or this or this? You can also go from the bottom when you go into the distribution menu. If you use second fars for distribution, you can arrow up and it'll take you down to the bottom. The last one is letter F. That's a little bit of a shorter way to get to letter A. So there's the binomial PDF. So 10 with the 4th. We already did 0. So let's do 3. So 3, the chance of getting 3 correct is about 0.25. And then, if I want to repeat that, I can use my little shortcutty thing, and then that just changes to 2 correct. Chances of getting 2 correct is about 0.28. The chance I'm going to get just 1 correct, just by guessing, is about 19.187, so we'll say 0.19. And then my 0 was 0.056. So if we put all those together, .776. So it's about a 78% chance that just by probability, you're going to get 3 or fewer. Okay? This kind of reminds me of back to when we did that thing at the beginning of the year about that smelling Parkinson's. We could absolutely look at the binomial probability of that problem. I think we should do that next time. We'll do that. If our chances are guessing, if the chances guessing, you know, what was the probability that she was going to get 12 out of 12, right? Depending on what the probability she guessed right the first time. That's a good binomial. I don't know if we had a probability of her guessing right any individual time, but we can do any of these very quickly. Okay. Last thing I want to show you, we're going to actually change A right here. We're going to talk about expected value and standard deviation, because when we do this, these two things, with a binomial problem, these are even easier. When we do these two things with a binomial problem, we don't have to have the whole table. With a binomial problem, with a binomial probability problem, there's a very easy formula for expected or average value. There's a very easy formula for standard deviation. We don't have to put the whole table in. Like we did with the Skittles problem, we had to put the whole table in. When we have a binomial problem, we don't have to put the whole table in. We don't have to calculate the whole table to figure out how to do these two things. All right, so let me show you. We've got a train, 8 o'clock every morning from Princeton, New York. It has 90% chance of being on time, any given day. We're going to look at 6 days, and X is going to be the number of days that the train is on time. So the first thing we're going to figure out is, well, about how many days are we going to expect the train to be on time? If there's a 90% chance it's on time, out of 6 days, about how many are we going to expect? Well, expected value, or average value, in a binomial problem, you can estimate by taking n times p. Now, that's such a great shortcut that sometimes you think, oh, I'm going to use that all the time. It doesn't work if it's not binomial. So like the Skittle thing where it was like, are there 50 or 51 or 52 or 53? That's not binomial because we had all kinds of different possible responses. If we have something where our responses are counting successes, then yes, average value, average number of successes, well, out of 6 days times a 90% chance, we're going to expect about 5.4 days out of 6 the train's on time. That's what I expect on average. Every 6 days, about 5 of those days it's going to be on time. If I want to know, well, about how much is that going to vary? To do the standard deviation, I can take the square root of n times p times 1 minus p. So in this problem, I'll cross that out for right now. In 6 days, we've got a 90% chance of being on time. That's P. We've got a 10% chance of not being on time. If I take that product and then take the square root of that, you got to remember to do the square root. Oops. That's going to be about 0.73. So it's always hard when we do average value and standard deviation for something discrete and we get decimals. It's hard to kind of wrap our head around it. So we can sort of round them off and go, okay, around 5 days plus or minus a day. So we're going to about 4 to 6 days out of 6, it's very likely the train's going to be on time. Okay. So we've got an average value formula and a standard deviation formula, but these are only good for a problem that fits the binomial standard, that has the binomial characteristics. Okay. So, With all of that, you should be able to take your review sheet, flip it over to the back, and do questions 3 and 4. Okay, so that's what I would like you to do right now. Go on the back of your review sheet and answer questions 3